I will be presenting the future of IoT adoption. So first, before we start, let me present myself. My name is Fayez. I am an electronics engineer. I have a BSc in electronic engineering, and I have 2 certificates from Cisco, which is the associate and the professional certificate. Also, I am certified by VMware as a network virtualization engineer and data center virtualization. I have an ITIL version 4, which is a set of standards and guidelines how to deal with IT operation and IT service desk. I have been with BATELCO for around 8 years, since 2014, working as a network operations center engineer and a service desk engineer. So let me start with today's presentation, and you can stop me anytime if you have any question, either by chat, I guess, if you are facing difficulties to speak up, or you can speak anytime to ask any question. So in today's presentation, first we'll start with a brief history of the internet. Then we will talk about Internet of Things ecosystem and Internet of Things application, and some of the application, which include smart cities, smart homes, and smart factories. Then we'll talk about what makes the Internet of Things possible and the power of combining the Internet of Things and cloud computing. So let me begin with the history of the internet. So the internet started in the 1960s when ARPANET, which is a network, was developed by the US military to connect their research bases across the country over the telephone line. So this was a very basic network, and it was privately owned by the US military. It was not open for the public, and they use it for basic functions, just to connect their computers and research facilities across the country. In the 1970s, the TCP/IP protocol was developed, and it allowed for easier to add and remove computers from the network, easier configuration. So it was a huge advancement at the time. In the 1980s, the internet started to look like what we know today. So the first commercial network was launched. Email was developed. DNS, which is domain name system, was developed, and it started to be open for the public. And again, it was still not mature. In the 1990s, the internet reached a high level of maturity. So it started to look like what we know today. So with the development of Windows 95 and some of the services that we know today, like Google, Amazon, Yahoo, and some of the programming languages that we are using today, for example, like Java. Up to this point, the internet was called the Internet of Computers. So to use the internet, you need a computer, and the devices connected to the internet are computers. This changed recently in the 2000s, where we started to have the Internet of Devices. So no longer it's restricted to computers. We have other devices like smartphones, tablets, smartwatches, and other devices connected to the internet. And this is the internet that we grew up with, which is Facebook. We have the services like Facebook, Instagram, Netflix, YouTube, and the other devices that we are using today. Now, up to this point, if you want to use the internet, you have to use it through a device. You have to use it through a screen. It's just like you are looking through a window to another dimension, which contain all the services that you are using. However, the next step, the next evolution in the internet, which is already started, which is we are no longer restricted with connecting only computers or only devices. anything can be connected to the internet, which is whether it's a device, an object, or anything you can imagine can be connected to the internet, which is the stage of the Internet of Things. And again, we are no longer restricted to using a device to access the internet or looking at it through a screen. You can interact with it. You can see it in your environment, devices scattered at your home, for example, or at your workplace, universities, anywhere. And you can interact with it by voice command, or even it can help you or serve you without you are even aware or interacting with it. So for this to happen, you must have an ecosystem around you. So the Internet of Things ecosystem, as we said, it's a set of devices, objects, and smart computers that are connected together and to the internet around you, in your environment, in your workplace. So for example, we have many examples of smart devices. You can see here on the screen some of them, like we have a smart lock here. We have smart appliances for your home, like a smart fridge, smart air conditioning, smart coffee machine. You can have smart security, CCTVs. You can have smart classrooms. You can have smart luggage, smart lighting. Of course, the idea here is to have an entire ecosystem around you in your environment that can serve you whether you are aware of it or not. A great example of the Internet of Things object is this little guy over here. I'm sure all the students are aware what is this. This is an excellent example of the Internet of Things. This is the AirTag from Opel. Maybe some of the students have it. Now, this is not a device. It doesn't have any screen. It doesn't have any way to interact with it. It's just an object. In fact, it's not even connected directly to the internet. It has a Bluetooth connection. However, seamlessly, it can connect to any other Apple device, whether it's an iPhone, iPod, or iPad. And through that device, it can communicate with the server and alert its owner of its location. So again, this device is dependent on other devices. It's the ecosystem that complete it. All the ecosystem complement each other. All the devices are complementing each other, working together for the user convenient in the user environment. Another great example is having an Alexa device in your home. Some of you might have an Alexa device, and you can command an Alexa device or any other smart assistant device like Google Assistant just by connecting it to the ecosystem, and then you can give it any command, for example, to unlock the door if you have a smart lock at your door. Or you can play music, command it to play music for you. Or you can, for example, if you have a smart fridge, you can ask Alexa what kind of groceries you have in your fridge. Or if you have the required material to make a certain meal, for example, if you have the groceries that are required to make this meal. So the ecosystem around you complement, the devices complement each other, and they are working for you. Another example is the integration of your smart door lock with your security cameras, with your CCTV system. So by integrating these two devices into your ecosystem, you can, for example, have the door unlocked once you approach the door. Or you can view your, once somebody rings the doorbell, you can view who's at the door without even having to get up or even lifting your phone to open the CCTV cameras. It can be displayed directly on your TV. since all three devices are connected to your ecosystem. So this ecosystem and these devices that we talked about take us to the next direction, which is the Internet of Things application. Now, dependent on the type of devices that you have and the environment you have, you can have limitless types of applications in everyday life. For example, if you connect the devices in your home into your ecosystem, you can have a smart home where the environment itself is smart. You can interact with your devices, with your services, with your security seamlessly. Another thing is you can have smart factories. So if the environment and the devices, the sensors in your factory are connected together in an ecosystem, you can monitor everything in a factory. For example, you can monitor the assembly line, you can monitor the production, you can monitor the logistic by monitoring the delivery or the shipments. Of course, guys, when I talk about monitoring, this happens through various means. You can have smart devices or smart objects scattered around in the factory, in the assembly line, to sense and to send data. Then you have servers or applications that analyzes the data and then takes decisions or keep you updated or inform you about the progress in your factory. So it's a whole environment, a whole devices. You can imagine it as thousands and thousands of sensors scattered around in your factory, all connected to the internet, all connected with each other through the ecosystem. A third example is a smart city. So if we are talking about smart homes, we are talking about smart factories. We can talk about smart schools, where you can monitor everything in your school, beginning from the performance of your children, or the school buses, or even the whiteboard in the classroom. You can take screenshots, or it can be uploaded directly to the cloud where you can access it anytime. Homeworks, again, live streaming of the lectures. You can have smart universities. You can have smart hospitals. You can have smart police stations. You can have even smart roads. So everything you can think about is possible. So once we talk about all of this, we are actually talking about a smart city. So when we have a smart city where everything in the city is connected to the internet and connected together, this can have a huge impact on our everyday life. Like the potential of high security, high convenience is really amazing. So let's take a smart home as an example. So as a typical living room, this is a typical living room. You have the devices connected together through the ecosystem. So through the internet, you can access, for example, your lighting. You can control your curtains. You can control your entertainment system. You can control your TV. You can control your security system. And again, these devices, it's not like just a one-way connection from the user to the device. It's a device to device also. So let's take an example. You are watching a movie. So automatically the TV can give a command to your curtains to shut down, or the lighting to dim, or depending on the type of entertainment you are watching, the news or a movie, or you are playing a game, the environment around you will set itself according to your activity. Another example is a typical kitchen, where you can have the devices connected into the ecosystem. So you have a smart fridge, you can have a smart oven, a smart dishwasher, and a smart TV. And through the Internet of Things ecosystem, where all the devices are connected together, you can, for example, watch a movie in your living room, and then you walk out into your kitchen. The movie will follow you from the TV in your living room to the TV in your kitchen. So this is just a small part of the convenience that we can have in our everyday life, and everything will be happening seamlessly. So without your intervention, without even you thinking about it. Now, moving on to the smart cities. So if we look at a typical smart city, you can have a smart home, or you can have a neighborhood of smart homes. So in a smart city, you can have a smart building, apartment building, where the building itself is connected to the internet and communicating with its surrounding. You can have a smart school. You can have smart transport with smart traffic lights. You can have a smart stadium within the smart city. You can have a smart airport. You can have a smart hospital and smart office building, as well as smart industries. So this is a smart city that we have everything is connected to the internet. So this can have a huge impact on our life, on our convenience. For example, you could be at home and you can check up on your children being in the transport being taken to the school. Or you can be at home checking how they are performing in school. In fact, everyone in your neighborhood will be doing the same. So you can be at your office building and checking out on your children at school. You can be at the work and making sure that your children reached home safely. You could be at work arranging a business trip. So these are just some potentials, some that the industry is heading toward this direction. You could be at a park, for example, checking your appointment. What time is it in the next day? And some of these that we are already seeing today in our current life. Like now you can book an appointment directly from your phone to your hospital. So now, if Internet of Things is so great, if it is so powerful, why haven't we done it before? Why the industry wasn't going in this direction before? So there are a couple of reasons and a couple of breakthroughs that happened in the previous years that allow us to have the Internet of Things today. First of all, the Ipv6 rollout. So the unique thing about the Ipv6 is that it has a very huge number of IPs. So if we are talking, for example, about a smart factory where you have thousands of sensors that are scattered along your assembly line in the cars, and every shipment that you are shipping, you have a sensor. So every sensor will require a unique IP. The limitation with IPv4 is that we have very limited number of IPs, public IPs that can be used by the public. So I think there is around 4 billion IPv4 IP. But with IPv6, you have like I can't even read this number. Like it's 34 with 38 zero that follow this. So, and there is a popular saying that that will give you an idea about how many IPv6 we have. Like they are saying that if we give every grain of sand on Earth a unique IP version 6, it will be enough, and we will have plenty more. So you can imagine how many IPs that are available for the public use in IPv6. It has an integrated security, and IPv6 support also auto configuration. So this is IPv6 is one of the pillars that allow the Internet of Things to happen now. The next thing is 5G. So 5G provide mobility. So you are no longer restricted on connecting stationary devices. So if we are talking about, for example, TV, we are talking about computer, we are talking about smart lock, refrigerator, air conditioning, these are stationary devices. You can connect them through LAN, you can connect them through Wi-Fi, no problem with that. But what about if we are talking about smart cars, for example, or we are talking about smart airplanes? We are talking about smart wearable devices like smart watches, smart eyeglasses. So 5G make this possible. We are able to connect mobile devices. And along with this, to provide faster bandwidth. So it's very suitable for example, streaming, for cloud computing. And it also has low latency. So the low latency for 5G is very essential when you are talking about real-time scenarios. For example, an autonomous car where the car is driving itself. So low latency can mean the difference between life and death if you have an obstacle, for example, or an accident waiting to happen. So the low latency is very important for the car to take the decision to stop or to move away from the danger. The third pillar is the fiber optic. Now, guys, here when I talk about fiber optic, I'm not talking only about the fiber that we have in our homes. I am talking about the infrastructure, the international cables as well. So fiber optics provide high bandwidth, and it provides reliability and longer transmission distance. So all the service providers that you are using, for example, Instagram, you are using Facebook, you are using Netflix, downloading games from PlayStation Store, everything is carried over international fiber optics cable that connect the Bahrain and every country in the world to the service providers. Another thing, let me go back to 5G. Another amazing thing about 5G is the high number of devices that one tower can connect. So if you are talking about a smart city, for example, where you have multiple smart homes and you have multiple sensors and devices in each home, you are talking about thousands of devices. You are talking about thousands of cars, for example, thousands of phones. So the technology in 5G allow one single tower to have more than, I believe, 1 million simultaneous connection to the tower. So it have a huge number of connections that can be utilized in the Internet of Things. Again, if you compare it to 4G, I think it's a few thousands. So if you are talking about a factory where you have sensors scattered along the assembly line, you have smart cameras, CCTV cameras, you have, for example, you have cars, you have logistic, you have shipments. So it doesn't matter. 5G can handle all of this on a single tower. So now that we talked about some of the smart devices or smart objects that we have in our environment, let's take a fridge, for example. Now, if we have a fridge that we can say it is able to recognize the content inside it. It has a camera, for example, that can take pictures and analyze those pictures and identify the product. Also, it can identify, for example, the expiry date of that product. It can send you a notification that there are some product expired, milk, for example, in your refrigerator. Now, I'm sure everybody who worked on video editing or worked with image recognition can know how much demanding this process for CPU, for RAM, for GPU. So it's very intensive processes to analyze the picture, to process it, and to identify what's in that picture. So how are we going to do this in a smart fridge? Is the fridge going to have a supercomputer inside it? Then we have to talk about the cost. Because if you have, for example, an i10 inside this fridge, and you have 2 terabyte, 3 terabyte of hard drive, and you are talking about RTX 3070s, for example, GPU. So this is 1000 PD worth of equipment, and the fridge itself will be 400, 500 PD. So you are almost tripled the cost of the fridge. And if we talk about another device, which is a smart air conditioning. So let's say we want this smart air conditioning to have a camera, and it will recognize you once you are walking into the room and will set the temperature for you. If you have more people, it will adjust the temperature based on the number of people. So again, this requires high processing, it requires image recognition. Like, you cannot fit that thing inside the air conditioning. All of these expensive equipment. And if we are talking about an air conditioning, it's around, I think, 300, 400, or 200 to 400 PD. So if you are fitting a 1000 PD worth of computer equipment, then you have multiplied it by 4 or 5 times the cost. So it's not really feasible. It's not cost effective. Nobody will buy it, to be honest. So we have other limitation in other devices. If we are talking about a smart lock, now if we want the smart lock to be able to recognize you when you are approaching your door and unlock the door for you without even you reaching it yet. So, okay, let's say that we are willing to accept the high cost. We are willing to buy the processing power, the storage, the everything. Now, the other limitation is how are we going to fit all of that inside a door lock? So it's very difficult because of the small size of the lock. Also, the power consumption. So you have to provide it with a steady power to cater for all that processing power. So how are we going to solve this? If you think about it, we already solved it. We already solved it in smart devices like Alexa. We already solved it in smart devices like smart lighting. We already solved it in smart devices like smart TVs. So in smart devices like like Alexa personal assistants, you can ask Alexa any question and it will answer you. You can request Alexa to play a song for you and it will play it for you. Now the trick here is that Alexa doesn't have all the information. It doesn't have all the songs. It doesn't have all the videos. What happens is that Alexa is connected to the internet. And when you ask Alexa a question, it will send your voice to the internet where it will be analyzed and converted into text. And the thing that you asked for will be searched about and then sent back to Alexa. And all of this happened within 1 to 2 seconds. The same thing happened with smart TVs. For example, let's say, let me ask you, what do you think the storage of a typical smart TV? What's the hard drive? For me, I believe I checked it last time on my TV at my home. I think it has 1 gigabit of hard drive, I think, storage, and maybe 100 MB RAM, and some basic processing power. So it's amazing for me that with this limited hardware, I can play, for example, 4K movie through Netflix. So you can imagine that I am playing a 4K movie over Netflix. So a 4K movie is at least 20 to 30, maybe 100 gigabyte of size. And I'm playing it on a device with limited hardware. So the same concept. So I am playing it over the cloud. So this is the power of Internet of Things and cloud computing. If we connect the devices that we have to the internet and to the service provider that can provide us with cloud computing, you can have the power of a supercomputer that can process millions and millions of data, that can process millions and millions of images and videos and sounds within seconds and send the result back to you without needing to have anything inside your device except the basic functionality of networking and processing. So the same concept we can apply to our smart appliances at home. So let's go back to our example of a fridge. So if you put a product inside your fridge, the fridge will take a picture of it, send it to the service provider or the cloud. And in the cloud, it will be analyzed, it will be processed, the product will be identified. And the result will be sent back to your fridge. Once the result is sent back to your fridge, then your fridge will be aware what's that product that you have placed inside of it. Now, this is just a basic example, and there are many benefits of cloud computing that can help the devices be a lot smarter with and being very, very, very cost efficient and power efficient. So another example is the smart door lock that we talked about. So a smart door lock with the help of cloud computing will not need any processing power, will not need to draw a lot of power, will not need a hard drive, for example, to store your images, your family, your kids, your friends. It will not need a hard drive. For example, if it have a security functionality to record if somebody tried to force open your door. So what happened that the smart door lock will only need a camera, and that camera will be streaming to the cloud, and everything will be stored on the cloud. Everything will be processed on the cloud, and the command to unlock or lock the door will be sent back to the lock itself. So this is the power of the Internet of Things when you combine the smart devices with the cloud computing. Now that we have talked about the Internet of Things and the Internet of Things ecosystem and how it is the next evolution in how we are interacting with the internet and how we are interacting with our service providers. So governments around the world started to recognize this, and they have started to foster the growth of the Internet of Things. For example, we have the European Union. They have invested a huge amount and included IoT as main pillar in their investment. They have also established an alliance for the Internet of Things since 2015. China is offering tax reduction for the companies and the firms that are working for the Internet of Things. Their goal is to advance the Internet of Things adoption. Their goal is to advance the development of the Internet of Things devices, concept, and everything. And they have created a council to enhance the progress of the Internet of Things. Now, this is just a two example from the global side, let's say. Now, in our region, in the Middle East and in the Gulf area, to be specific, we have the UAE, where the UAE have set up an advisory committee for the Internet of Things, and they have established a framework for the Internet of Things services, and they have included the Internet of Things in their national strategy. So you can imagine that this is a nationwide strategy, and they have included the Internet of Things. This is just to give you an indication how serious are the government about the Internet of Things and how they are investing in the Internet of Things for the future. We have in KSA, where they have invested 1 million in entrepreneur fund, and they have issued a regulatory framework. And they have initiated an annual conference for the Internet of Things. So I don't know if you have heard about the project that Saudi Arabia is doing, which is the NEOM City. They call it the Robot City. They are planning to do it on the coast over the Red Sea. So it's definitely a huge investment for the region, and it's definitely going to push the concept and the progress of the Internet of Things forward in the coming years. So in Bahrain, let's talk about Bahrain. In Bahrain, we have made a huge progress in our, let's say, investment in or the potential for investment in the Internet of Things. Like we have an excellent fiber infrastructure, which covers the whole country. We have an excellent 5G coverage, which covers the whole country. In fact, I think Bahrain is one of the first countries to be nationwide coverage in globally. It's definitely one of the first countries in the region, in the Middle East. So we already have made a huge progress. And one of the examples that we have currently is EWA. So EWA right now are rolling out smart meters for every home. So these smart meters are connected to the internet, and the operators in EWA can take real-time reading of the meter. Also, they can have alarms for regular consumption. If you have a leakage, for example, in your house, they can notify you. So they started rolling out this to homes and to businesses in Bahrain. Now let's talk about potential. Let's talk about future cases. One of the future cases that we can have in Bahrain is Bahrain Metro. As you are aware that Bahrain already has, I think, already signed an agreement, or they're already planning to build